Hello, today I'm going to give you some equations that you are going to be able to calculate different energy that's stored in different manners. And you already know some of this. You know we studied elastic energy, energy in a spring, and you know that the elastic energy can be found by the area under that spring graph. And so that would have been force, which is on your y-axis, and length, which is on your x-axis. So force times length divided by 2 gives us the area of that triangle. And therefore, you can calculate the elastic energy that way. The units are going to be the units of force, which is newtons, times length, which is in meters. So newtons meters. And that actually is something called a joule. So our unit for energy is a joule. Don't confuse that with newtons. Newtons are force units. All right, now there's another way to calculate the elastic energy, and that is to use this equation right here. Now, I'm not going to prove this equation to you, but we will see the units still come out to be joules. All right, so why do the units come out to be joules? Well, this equation says that the elastic energy is 1/2 times your spring constant. And remember that spring constant was the slope. And so it was newtons for every 1 meter. My meter should be moved over here a little bit. Newtons for every 1 meter. And then this is the length of stretch again, but it's the length of stretch squared to find the energy, the elastic energy. And so there's the length squared, meters squared. Now, this meter cancels one of these meters out when you do the calculation, and that means newtons and 1 meter are left. It's still a newton meter or a joule. All right, so either one of these equations can be used to calculate the elastic energy. You need to record these equations somewhere because you're not going to want to come back in this video all the time and check these out. So record them on a sheet of paper that you do not lose, or in a notebook or something. You're going to be using these off and on for a while. All right, gravitational potential energy. How are you going to calculate that? Well, the first person that did the worksheet from yesterday said, well, gravitational potential energy must depend on 3 things. And they said it depends on the mass of the object, how much gravity is on that planet, and the height of the object. All right, so let's look at some rocks on a hill and see how that relates to that equation for gravitational potential energy. Gravitational potential energy. So we got 2 rocks on our hill. One is really big, one is small. Which one is going to have more potential energy? Well, I think you'd agree that the big one has more potential energy. If the little one rolls down the hill and hits you in the ankle, you might not care. But if the big one rolls down the hill and hits you in the ankle, it might break your leg, and you're going to care. Right? It stores more energy, and that energy can cause a change in your leg. All right, so mass is important in that equation. What else is important in that equation? Well, gravity is going to be important in that equation. 10 meters per second every second is the acceleration due to gravity on Earth, but it's not on every planet or on the moon. So imagine that we're on the moon. These rocks do not have as much energy stored in them, and if they roll down the hill, they will not get going as fast. All right, so on that planet, it will have less potential energy, gravitational potential energy. And next, what else matters? Well, you can imagine that if I make these on a hill twice as high, that they are going to have a lot more gravitational potential energy. In fact, they will have twice as much gravitational potential energy. So the 3 things that determine the amount of potential energy due to gravity is the mass of the object, the gravitational acceleration on Earth, that's always going to be 10 meters per second every second, and the height. Just multiply mass times the gravitational acceleration times the height. There's your equation. Make sure you record it and you know what it means. Now, what are the units going to be? You should know that the mass times the gravitational acceleration of an object is the force. That's the gravitational force. So that is newtons. And then multiply that by the heights. That's going to be newtons times meters. Wait a minute. That's joules again. That's what we saw before. Newtons times meters is a joule. So this is still going to be energy in joules. I'm going to stop now and record those equations, and we'll come back in a little bit.